Hey, I'm Dave. Welcome to my shop. I'm Dave Plummer, a retired operating systems engineer from Microsoft going back to the MS-DOS and Windows 95 days, and recently a friend asked me a simple question on Facebook. If he had a matrix of 100 by 100 LEDs, could I write a clock for that? Now, I didn't have a matrix that big on hand, but I did have a 64 by 32 around, so I decided to see just how long it would take me to do it. Come along for the ride as I draw the circles, add the hands, and display the time, all from first principles, right here in Dave's garage. Okay, to draw our clock, I'm going to use the NightDriver project, a free open source project that I wrote, or that I helped write, which is up on GitHub. And we're going to start there because it allows me to just take an effect class called the LED strip effect and implement the draw method, and that's all I need to do for plumbing. That'll keep it nice and straightforward for you. You're not learning my class library, and the only functions I'm going to call on it are things like draw line and draw circle. That should be as self-explanatory as the old Turtle Graphics days. So one thing worth mentioning is that for me, the camera's up there and the code is right there. So if I'm looking down there, I'm not ignoring you, I'm looking at code. Before we can draw a clock telling you what time of day it is, we need to know what time of day it actually is. So let's do some definitions for the number of seconds per hour and so forth, and then we'll call the system to find out what time it is. With those squared away, we also want to define how big our clock is going to be. We'll do that as a constant here because it won't change throughout the run. Now, we don't know whether the matrix is in portrait or landscape, or if it's square for that matter. I know that physically mine is 64 by 32, but I want the code to run on pretty much any matrix. And so I'm going to have to look at the layout of the thing, figure out whether it's in portrait or landscape, or at least take the narrowest of those so that I don't draw outside the bounds of the very center region. This will give me a radius which is the smallest of either the height or width, whichever is smaller, and then it's going to take half of that, because we're doing the radius, and it's going to back off by 1 so that everything stays on screen. And now let's get the time of day from the system. There, tidy that up a little bit. And the reason I'm doing that addition to the hour here is because I set the clock via NTP in code that you don't need to worry about today, but it's automatically set to the millisecond almost from the internet. Now the problem is that it's assuming a time zone, and I am 5 hours off of that time zone, so I'm just going to manually adjust it for today. And if I want to figure out the locale information and time zone settings and all that, which probably aren't set right on the ESP32 anyway, I will then do that later. But for now, I'm just going to hard code to my own personal time zone. Let's simplify some of the declarations by declaring some variable consts. And those simple definitions will just allow our code to be more readable by saying hours, minutes, and seconds instead of pulling data out of the structure all the time. And now we can actually get down to the business of drawing a clock. The first thing we're going to do is clear the screen. With that done, let's draw a circle which corresponds to the outer ring of the clock itself. Next, let's draw a tiny circle right at the center, which will be the dot where the hands attach. Same thing, but we'll give it just a radius of 1. That should run, compile, and draw 2 circles all on its own, so let's see if we can actually get that working. Well, it compiled, and it's uploading. And we have circles. It's the beginning of an LED clock. And now we have to bust out a little geometry and trigonometry. SOH CAH TOA was a long time ago. SOH CAH TOA, sine over hypotenuse, cosine adjacent over hypotenuse, TOA. Tan opposite over adjacent. There you go. And that's from high school. Not bad, eh? But how could one forget SOH CAH TOA? Couple of local variable definitions. We're going to work in degrees because the relationship between 360 and 12 hours is just so handy that I don't want to have to work in any other form. But before we call the system trig functions, we need to convert them to radians. Now we could divide by 57 point whatever it is, 57.29577, something like that. But we could also just simply call the degrees to radians function. That's not actually a function, it's just a constant. So let's do we'll make it this, even a little less readable, but simpler. Angle, we're going to multiply it by the degrees to radians, which is this constant here. And because it's a float, I'm actually going to promote this to double. Because I'm going to, this code is compiled with doubles set to double precision and floats set to single precision. And I'm just going to use double precision because I believe, I hope, that's what the CPU can actually do natively. Maybe it just does floats and I'm backwards. I'll have to find out later. What I want to do now is draw the ticks that run around the inside of the circle that indicate where the hours are. We'll do that by going every 30 degrees so that we wind up with 12 of them and drawing a small couple pixels long tick at the end of the stroke. And when I say at the end of the stroke, what I'm doing is I'm starting at the center and I'm using the sine and the cosine to extrapolate in the right direction, and then I'm making 2 points. One almost at the edge, then one at the edge, and drawing from there to there. That should render 12 ticks around the clock, each at the right angle around the outside. That might make more sense when you've seen the actual code, so let me go ahead and try to write that. That's going to be our start point, which is the very outside at the radius. So we're basically going a full radius away from the center. Now we want to come back just a little bit, so we draw from just a little bit inside to the outside. Uh-oh. And we'll draw them in red for a little extra effect. Let's try this and see if this much works. Still compiles. Still links. Yeah, no, I don't think that's right somehow. Just not sure. What have I done? Maybe that constant isn't what I think it is. I don't see anything else obviously terribly wrong here, so let me just try doing the angle to radians conversion a little more conventionally. Well, there's my bug. Copied and pasted and didn't update the number. Oops. That's rather embarrassing to do live, or semi-live, but it happens. And because I was looking at it, and I was staring right at it, and I still didn't see what the problem was, even more so. So those are my little tick marks that will represent the hours on the clock. There's not enough resolution here to draw numbers, but you could use the position of the start point of the tick as your location to simply draw the number 1, 0, 1, 2, 3, 4, 5. Well, the next thing we need are some hands. So let's start with the second hand. There are 360 degrees in a circle, and there are 60 seconds in a minute. Divide one by the other, and you get 6 degrees per second. Oh, it's a swing and a miss for Mr. Plumber. So why don't you call him and let him know? Hello? Oh, too slow. Well, you can't say we didn't try. Oh, this one's a shambles. Can't decide if the second hand should go to the edge or stop with the tick, but because I think the minute hand is going to have to be pretty close in length, I'm going to have the second hand go all the way out to the edge. So I'm getting the angle in degrees, converting it to radians, and then I'm using the sine of the angle, and this should be cos. I already caught a bug. There we go. Oh, good show. And that will extend out to the edge of the circle from the beginning. So we'll draw a line from the beginning out to the edge, and that will be our second hand, and it will follow how many seconds have elapsed. Are we setting seconds already? I believe we are. Yes, we are. So, in theory, this should work and start ticking. Oh, the irony. Oh man, not a good day. Not a good day. You'd think that I would be able. Oh yeah, matrix center X, matrix center. I hope you guys spotted that before I did. Quite so. Let's see. What else did I bone up here? X3 is matrix center X plus the sine of the angle times the radius to go all the way out. Start at the center. Maybe this should be minus. I'm trying to remember my math. Yes, this should be minus cosine. That's why. Silly grade 8 math. Grade 10 math, whatever it is. I'm not making fun of the math. I had to look it up. I won't kid you. Well, we've got a clock and we've got a second hand, but it's not moving. I wonder why that is. Seconds times 6. Seconds is TM seconds. And TM seconds is from local time, and local time. And it's pulled from the current time, and current time. It's alive. We've got a ticking second hand now. Let's make sure it goes at least around once. I'll fast forward that for you, and we'll see how it looks. See if we back that radius down a little bit, maybe. That'll bring the second hand back inside so that it doesn't extend past the boundary of the circle. And now we can add the minute hand. I'm going to change the second hand to white, and we'll keep the minute and hour hands yellow. In theory, let me look at it this time so I don't just type in some boneheaded mistake all over again. X3, Y3, matrix center X, matrix center Y, plus minus, sine cos, radius minus 3. And I'm going minus 3 there so that it'll come back just inside of the tick marks, I believe. So it'll extend from the very center dots to just about the tick marks, and that sounds about right for a minute hand. You'll see the clock sets itself a few seconds after the code starts up, and that's because it goes out to the internet to get that. So it starts out with 0000000 time, and then gets to real time, and it will jump. And right now it is 12:05, so the hand actually looks right. It looks like all we need now is an hour hand. Now, remember the hour hand has to move a bit as the minute hand goes around, right? The hour hand will actually get closer to the next hour. So let's do and we'll go halfway out to the edge. So that's why it's radius over 2, because we're going to start at the middle and we're going to go halfway out, and we're going to call that the hour hand. Looks about right. Let's see what that gives me. And then a time jump to the current time. There you go. 12:09. Little hands on the 12, big hands on the 9. I just want to make sure the second hand doesn't poke outside. And it seems not to, so that's the main thing. Now to get a little more animation here, let's put a sweep second, or a 60th of a second sweep timer on this. We'll go up above the second hand. Now I need the fractional number of seconds here, which I can't get from the TM structure. So I know that I have a double value, which gives me the current application time. So that's what I'm going to use in this case. You would want to call it Unix time, or anything that gives you the number of doubles that have elapsed since January 1, 1970 in a fractional manner. Yes. Okay, what this code is going to do is much like all the other hands, except it's going to draw from the outer radius to 3 inside of the inner radius. So it'll be a little tick, kind of like our little red tick marks, but it's going to sweep around as it goes. I'm not sure if the frame rate's going to be fast enough. We'll try that in a second. Defaults to 30 frames per second. I can up that to 60 in order to get the 1 line per tick. But the camera's probably not running at 60 anyway, so. Did I have a mistake? What happened here? Oh, I redeclared all these guys. Don't want to do that. Boop. All right, we're uploading. There, a little sweep hand. This does poke out the outside, though, unfortunately. So let's do radius -1, just to be certain. And should I come back? I'll come back one more. We'll come in one. Let's try this. Should look a little better. What? What did I do here? Forgot my parentheses. Plus minus, sine cos, radius -1, radius -1, radius -4. There you go. Looks kind of cool. I'm going to make one final adjustment here to see if I can improve the frame rate by overriding a virtual function in the base class, which is desired frames per second. That's a cost. Let's return 60. Don't worry too much about this. It's in the base class, you're allowed to define how many frames per second you actually want, so that it's not wasting a bunch of time drawing you over and over and over when it doesn't need to. But when we're doing something that needs low latency, like drawing the tick mark that goes around 60 times or 60 places per second, we probably want more frames per second than 30. So there we go. The camera may not pick up the extra frame rate, but I can see it, and that's what matters. With that, let's take a quick run through the code one last time so you can see it as a whole. I'll zoom out here. This is the entire function. And if we step into it and look at it, it gets the current time. It adds 5, in this case, to the current time in order to get the local time zone. And then it pulls out the hours, minutes, and seconds that we're going to render. It clears the screen and it draws an outer circle, which is the clock body, and an inner circle, which is where the hands mount. Next, we declare our local variables. And we sweep around from 0 to 360 degrees, stopping 12 times, which is every 30 degrees. We draw a small tick mark, which runs from radius -2 out to radius, and we draw it in red, and those are the red tick marks that you can see in the clock. Next, we draw this little blue sweep hand. Fraction is the fractional part of the seconds, because what I'm looking for is how far along I am in the current second, and I want to know how far around the clock to draw it. So I just take the fraction and ignore the entire second amount. I then multiply that by 360 degrees, which is the fraction of 360 that I am around the clock for the current second, and I divide by degrees per radian. We then do it like every other calculation here, plus minus sin cos, to go from -1 of the radius to -4 of the radius, which is just inside of the outer circle. We then draw that line in blue. For the second hand, much the same thing, except we'd go to just the radius -1, so we just touch the outer circle. The minute hand is a little inboard. It's 3 ticks inboard of the radius, and it's drawn in yellow. The hour hand is half the radius, and it's also drawn in yellow. And that's it. That's the entire clock. So there you have it. It's 20 after 12. I don't know what time I started at, just before 12, I guess. So a clock and 20 minutes, and a little less than that in real time, obviously. So, or a little more than that in real time, a little less than that edited time. If along the way you found today's episode and the coding to be any combination of entertaining and informative, I'd be honored if you'd consider leaving a like and subscribing to my channel. If you have any interest in matters related to autism, Asperger's, or ASD, please check out my book on Amazon, Secrets of the Autistic Millionaire. It's got nothing to do with money and everything to do with living a successful life on the spectrum. It's everything I know now that I wish I'd known back then. Remember, I'm mostly in this for the subs and likes, so please do be sure to leave me one of each before you go today. In the meantime and in between time, I hope to see you next time, right here in Dave's Garage. This little chair will be waiting for one of you, and a rocking chair for another who likes to rock, and a big armchair for 2 to curl up in. All next time on Dave's Garage.